Welcome back. Today we're going to go over sample space, and sample space is pretty simple. We're just going to go ahead and list a couple of things there, but to understand sample space, the sample space describes all of the possible outcomes of an event. So what that means is it describes everything that could happen in a given scenario. Sample space, it can be displayed with lists, tables, or tree diagrams to determine the probability of simple or compound events. So if we use sample space, we're using it to try to find the probability of something, but it's only those things that are happening in the event that could occur. So for instance, the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of this game or the game? It's not possible for the Jets to win. Now, as much as I love the Jets, which is, I know you guys can judge me later, but what I'm saying is that if the New England Patriots are playing and the Dallas Cowboys are playing, the Jets won't win. And the reason why is the Jets are not in this game. It's only the Patriots and the Cowboys. So the possible outcomes of this game could be the Patriots win or the Cowboys win. Now, you could say it the other way, and you could say the Patriots lose or the Cowboys lose, but that's the only possible thing that could happen in the game. And then number two, rolling a number cube. If a number cube is rolled, what are the possible outcomes? Well, if it's a regular number cube, it would be 1, 2, 3, 4, 5, and 6. Those are the things that could happen. I cannot roll that regular number cube and have it roll a 24. Because on a regular number cube, there is no 24. It's only 1, 2, 3, 4, 5, 6. Okay, listing or tables, using some information here. For breakfast, Jamie can choose from cereal, eggs, or a muffin. She can also drink coffee, orange juice, or milk. What are all the possible outcomes and how many total outcomes are possible? So first off, we have to list the information because it wants to know what are the possible outcomes. Well, she could choose to have cereal, and if she chose cereal, then she could choose to drink coffee, orange juice, or milk. If she didn't choose cereal, the next option in here is eggs. So she could go ahead and choose eggs, but then she could choose to drink coffee, orange juice, or milk. And then the next one would be she could choose a muffin and drink coffee, orange juice, or milk. Now, in this one, we're not assuming that she didn't choose, that she's like, well, I don't want to eat cereal, eggs, or a muffin, or I don't want to drink coffee, orange juice, or milk. Like the choices are the things that she can choose, and that's what are the possible things. We're not talking about the things that she's not going to be doing. It's based off of the information that's here. So those are the possible things that could be chosen. And from that, I would then take the probability of 3 of them and times the probability, or not the probability, excuse me, the 3 total here times the 3 total there to give me 9 total outcomes. Now that's the quick way to do it. I could go through and count each time there are 3 cereals, 3 eggs, or 3 muffins based off of the drinks that are there, and that'll add up to 9 as well. But the quick way would be to take the total number of options for the first choice, timesing it by the total number of options for the second choice, timesing it by the total number of options for all the other choices, if there are more choices than 2. Okay, number 4. At registration, a student can select from Spanish or German class, two options there, as well as art, music, or theater. There's 3 options there. So what are the possible outcomes and how many total outcomes are possible? So we have 2 questions again. We need to list the possible outcomes, and then we need to see how many total there are. So they could choose Spanish or German. So I'm going to go ahead and list that. Spanish or German. If they chose Spanish, they then could choose art, music, or theater. If they chose German, they could choose art, music, or theater. And there's no other options. So that means that we would have 2 options times 3 options would give you 6 possible outcomes. Meaning there are only 6 combinations that can occur between those choices. Okay, next, a fair coin is tossed 3 times. What are all the possible outcomes? How many total outcomes are possible? And in this one, I'm going to do a tree diagram. So if I were to flip a coin, the very first thing, if that first flip, I could get heads or tails. And then depending on what I get, on the second time I flip the coin, it would be heads or tails. Now, in this one, if I got heads the first time, then I could get heads or tails the second time. If I got tails the first time, I could get heads or tails the second time. And then I go a step further. The third time I flip the coin, each one of those could possibly be heads or tails. So the possible outcomes are all listed here. I could get heads, heads, and heads, 3 heads in a row. I could get heads, heads, and tails, heads, tails, heads, heads, tails, tails, and so forth. Now, how many total are there? Well, if I look at the possible on each round, the first time I flipped it, I had 2 possible. The second time I flipped it, I had 2 possible. And the third time I flipped it, I had 2 possible. So that means that I'm going to have 2 times 2 times 2, which gives me 8 possible outcomes. Okay, next question. We're going to go ahead and create a list. When we use this information to answer the question, then we'll use it. So it says Amanda will roll a number cube and flip a coin. If Amanda rolls the number cube once and flips the coin once, then what are the possible outcomes in which the number cube lands on an odd number? So in this scenario, all I care is that it's an odd number. So on a number cube, the only odd numbers that are listed are 1, 3, and 5. So I would go ahead and list the possible outcomes because it doesn't say how many total. It wants to know what are the possible outcomes. So I would say, yeah, she could get 1 and heads, or she could get 1 and tails, or she could get 3 and heads, 3 and tails, or lastly 5 and heads or 5 and tails. Those are the possible things that could happen if she wanted to roll an odd number. Whereas the other stuff doesn't really matter, then that would be our list. Now, if she said she wanted to roll an odd number and get tails, then it would be 1 tails, 3 tails, 5 tails. But it only asks for the one thing to occur. Okay, number 7. The 2 spinners here, they're spun at the same time. What are the possible, or what are all the possible outcomes of the 2 spinners? So if I list them, I would go ahead and just start out. I could get 1 in yellow, or I could get 1 in red, 1 in blue, or 1 in orange. Now, that was the one thing that could occur. Now, the second one would be 2 in yellow, 2 red, 2 blue, or 2 in orange. Those are the only things that could happen with those 2 spinners. Okay, next one. We're going to create a tree diagram again. We're going to use the information to answer the question. A clothing line has shirts in red, blue, and white, and pants in gray or khaki. How many different combinations can be made with this clothing line? So if I were to do this, I would start out by saying that we have a red clothing, which can be gray or khaki pants. We could have a blue shirt with gray or khaki pants, or we could have a white shirt with gray or khaki pants. So looking at those combinations there, the first choice, I'd have red, blue, or white. There are 3 there, and it says there how many different combinations can be made. Well, that's 3 choices with 3 shirts and 2 pants, so that means we do 3 times 2 to give me 6 possible outcomes. This clothing line can only have 6 different outfits that are unique. Number 9, when buying a car, Esther can choose a 2-door or a 4-door car with leather or cloth, interiors in black, silver, or white. How many different combinations can be made with the car options? So the very first thing with this one is we would notice that the choices that she can make using a tree diagram, she could either choose a 2-door or a 4-door. Now, if she chose a 2-door, she could choose leather or cloth. If she chose leather or cloth, she could then choose the interior to match in black, silver, or white. Black, silver, or white. And then again, 4-door with leather or cloth in black, silver, or white, and black, silver, and white. Now, because it says here how many different combinations, it doesn't say list all the combinations, it says how many different. Well, she could choose, for the first choice, there are 2 options, so 2. The second choice, there are 2 options, so 2. And then the third choice, or 3 options, 3. So I would go 2 times 2 times 3, meaning there are 12 different types of cars that she could choose from with those options. All right, last question. So now this one, I don't think there's enough information to answer it the way that I did. So I'll be reading it slightly different than what's on the screen. But it says here, Sergio tossed a 2-sided red and yellow counter chip 3 times. Now it doesn't say 3 times, but it needs to say 3 times. It was a typo. We're going to create a tree diagram to represent all the possible outcomes for the coin landing on red or yellow. Now, in this one, it's just like a regular coin, but instead of having a quarter or something like that, it's a counter chip that's red and yellow. So if I were to flip the coin once, I could get red or yellow. If I were to flip the coin the second time, I could get red or yellow. And if I were to flip the coin a third time, I could get red or yellow. Now, if you'll notice, this one right here is listing red is my first toss, red or yellow is my second toss, red or yellow is my third toss, and I could find out that one. Now, if I flipped red the first time, this is what my list would look like. But if I flipped yellow the first time, then it would be yellow, and then red or yellow, and then red or yellow for those options. So if I were to go through and list them individually, I could flip red, 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 yellow, red, yellow, red, red, yellow, yellow, and so forth. But it doesn't say to list them. It says what are the possible outcomes. Like I want to know what are all of them, and if I were to do that, um, like I would go ahead and list them in this tree because then I'm not going to have to write red, 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 yellow, red. Like the tree diagram is a really quick way to write them instead of listing out each one, trying to remember which one you haven't done yet. Okay. Hopefully this was helpful for you. If you have any questions, please let me know, and have a great day and stay safe.